In the last video I showed you how to set up Xdebug to generate profiling files. In this video I'm going to give a quick tour of KCachegrind, a tool to visualize these profiling files. KCachegrind is a very powerful tool, but sometimes it can be a little bit overwhelming of what it is showing. In this video I'll give a quick overview of where all the things are, and in a future video I'll show you how to effectively use KCachegrind to find performance bottlenecks. KCachegrind doesn't allow me to select a larger font, so I'll use my desktop's zoom in features to have a look at these things, because otherwise it will be too small. Let's focus on the left side column first. There are 5 columns that are of interest. Incol stands for inclusive time. This is the amount of time spent in this function and all the functions that were called from this function. At the moment, main is at the top and it shows that it took 100.0.1% of the time. That is of course a rounding error. The second column is self. This is the amount of time spent in this function, discounting the time spent in functions that were called from here. To no surprise, main only accounts for 0.1% in this case. The third column, called, shows you how often a specific function was called. The fourth column is function, with some additional changes made. For example, files that are required or included don't just all list up under require once or include once. Instead, they're postfixed with the file name. This makes it easier to correlate in which specific file things were. Additionally, PHP's internal functions have been prefixed by the pseudo-class PHP. This again makes it easier to group for things later. The fifth and last column is the location, or the file name in this case, with the addition of PHP:internal to signify a PHP internal file. In the top right there are 5 tabs. The first one, types, allows you to switch between profiling time, which is in 10 nanoseconds, or also in memory. Xdebug's profiler shows you memory profiles as well, with the caveat that at any time PHP's built-in garbage collector could in, skewing your result. If you want to do memory profiling, I would therefore recommend that you turn off PHP's garbage collector. Let me select a function so we can show some more features. The callers tab shows you which function called the function that we have selected. In this case there's only one, event dispatcher dispatch, and it was called 19 times. The all callers tab shows you all the previous functions, as well as the distance to this function call. The distance pretty much means how many different levels of functions calls fit in between. A distance of 1 means that this is a direct parent, a distance of 2 means a grandparent, but it is also possible that the distance isn't a single number because there are many calls and hence a different distance. For example, the function that we have selected, event dispatcher call listeners, was called in a distance from 7 to 27 from main. The callee map is a visual representation where the area shows you how much time was spent in that function, not spent in other functions. This can give an interesting overview about which functions on its own take up a lot of time, or rather, the logic in these files take up a lot of time. Those are usually a good candidate for looking into. The fifth tab in the top right is the source code tab, where you can see inlined how functions were being called, how often and how much time that took. For example, in our selected call listeners method, there were 85 calls to Symfony component event dispatcher debug wrap listener invoke, which took up 57% of the full request. This isn't in nanoseconds at the moment, because in the top we have selected relative, which shows you only things in percentages. I will now switch back to main to show you one of the more useful features of KCachegrind, which is the call graph in the lower right. This tree shows how all the different function calls relate to each other, and it also shows you where time was spent. Through a require file, it actually starts Symfony's kernel, which takes up 96% of the request. This is then split in 2 major things, which is application kernel handle, as well as application terminate. The thicker the arrow, the more interesting this specific function call was. You can dive in by double clicking on the function calls. In the mini view, that you can see here on the left hand side, it shows you a very long tail. This often indicates the slowest spot where most of the time has been spent. And this is often also a good location to look for optimizations. But as I said, we'll be looking at that in a different video. When you select a function, the source code view in the top also updates, giving you an indication where things were specifically called. Xdebug's profiler only shows information for function calls and not for language constructs. This I hope to add in the future. From this video, I hope that you have learned where to find all the distinct information that KCachegrind provides. If you're on Windows or Mac OS X, then there's no KCachegrind tool available. Instead, there's something called KCachegrind, which pretty much is the same application, but targeted for a different windowing environment. I'll provide a link in the description below. Thank you for watching this video, and I'll see you next time. If you enjoyed this video, please click like and subscribe. And I'll hope to see you in the next video, where we'll be diving into how to find performance issues with Xdebug's profiler.